name is Anagaha and I'm part of the Data Science Discovery team, and in this video today we're going to be doing a question on the Bayes theorem and seeing specifically shot types and scoring. So let's go ahead and get started. So here you're studying the different types, shot types of basically your favorite basketball players, right? And notice that particular types of shots have differing chances to make it and score successfully, right? So you're seeing these three different types of shots here, free scores that have a corresponding 25% probability or 25% chance of occurring, layups, which is 45%, and then finally three-pointers, which is going to be the 30%, right? So assume, among the shots taken, when your favorite player shoots a free throw, they score successfully 70% of the time, right? So when they go for a layup, they score successfully 75% for the time. And when they attempt the more difficult three-pointer, they do not score, so they miss 80% of the time, right? So there's these different probabilities here. And given that specific event, the probability of success is different for each of these three types of shots, right? So our question here asks us, the first question we're dealing with is what is the overall probability that they successfully score? So in that the player successfully scores, right? So there's different ways of solving this. And, since we have a lot of questions to get through, I believe the easier approach for this question is going to be forming a table where we where we can map out all of the probabilities, right? So that other questions, such as those involving conditional statements, are easier to do when we have all the probabilities, nicely displayed on the table. And yes, you can use the formulas, you can use a Bayes theorem to do this. That is a perfectly valid approach as well. But the approach I'll be taking here is, specifically making like a table to basically display all my probabilities, right? So here you have three different types of shots, right? So there's going to be, basically there's going to be free throws, and then layups, and then there's going to be three-pointers. And for each different type of shot, right, there's going to be a probability of success and probability of failure, right? So here I'll just make my two columns, which is going to be success and basically failure, which means you missed a shot, right? So our probabilities are just going to go, within these columns. And then finally, we're going to have our marginal totals, which are going to be in the margins. That's why they're called the marginal probabilities, right? So first of all, it's when your it says the free throws occur 25% of the time, right? So before we kind of start, let's pick an arbitrary number of shots that are taken. So like the final total number of shots for the scenario that we'll make the table based out of. So I like to pick a number which is pretty large, such as 100. I wouldn't recommend doing something less than that, because then you're going to be dealing with smaller numbers with decimals, because we have smaller probabilities here. So let's take a n number of shots, right? Let that be 100. And then based on these probabilities, right, it's easier to basically count the number of shots that are free throws, that are layups, that are three-pointers, how many of those shots are successes, how many are failures, and that will, and by making a probability table basically with these counts, right, we can find it easier to calculate the actual probabilities. So out of 100 shots, basically 25% of those are free throws, right? So the total number, like right here, this area, the total number of free throws is going to be 25% of 100, 1/4 of that, which is just 25, right? And then for layups occur 45% of the time. So for layups is going to be 45. And then finally, three-pointers, that's going to be 30% of the shots, 30% of 100, that's just 30 shots, right? And then finally, these all, if you calculate them, they all add up to 100. So that's correct, right? And now it says, among the shots taken, when your favorite player shoots a free throw, right? So again, we're going to be looking specifically at this row here because we are talking about free throws, right? So we only want to deal with that row, with that with that section, right? So when the player shoots a free throw, they score successfully 70% of the time. So that means 70% of whatever free throw, however many free throw shots there were, are successful. So if we had 25 total free throw shots, 70% of them, or basically 17.5, right? 17.5 of those shots will be successes. And in this, I guess, context, the decimals may not make a lot of sense, but because we're dealing with counts and we want exact probabilities when we calculate them, we want to keep the decimals here, right? So no rounding. And then so if 25 out of 25, if 70% or 17.5 of these shots are basically successes, then you know that 7.5 of them are going to be failures. And then similarly, when they go for a layup, they score successfully 75% of the time. So that means out of 45 shots, 75% of them will be successes, or 33.75. Right, so 75% of the total 45 shots are going to be successes. And then finally, for failures, that's going to be 11.25 failures. That's just, 45 minus 33.75. And then lastly, when they attempt a more difficult three-pointer, they do not score, so they miss 80% of the time. So before we were kind of filling out the success column, but here we're going to be dealing with a failure column because we are given the probability for a failure. So that means if I had 30 3-point shots, 80% of those were basically failures, right? So 80% of 30 is just going to be 24. So 24 of those are failures, and then 6% of them are successes, right? And then to find these totals here, we basically just have to add up the corresponding columns to get our final successes, right? So the total number of successes basically in all of our 100 shots is just going to be 57.25. And then finally, our failures here will be, it's just 7.5 plus 11.25 plus 24. So that's just going to be 42.75. And then if you add these up, basically the marginal totals here, they should be adding up to 100, which they do. So we know this table makes sense, right? So now that we have our table, it's a lot easier to solve the actual probabilities, right? Because we can, if there's any conditional probabilities, right, we can just look at that subset or that row or corresponding column. So if we go to our first question here, what is the overall probability that they successfully score? Well, out of my 100 shots, 57.25 of them were successes, right? So the probability that I score here is just going to be my probability of successful shots divided by, not the probability, but the number of successful shots divided by the number of my total shots, right? Because probability is just number of expected outcomes divided by number of total outcomes, right? So it's just going to be 57.25 divided by 100, which is going to be 0.5725. And here, since we want the answer as a decimal, it's just 0.5725. And that's correct. So now it says, what is the probability that a successful shot was a free throw? So given a shot was successful, right? Given a shot was successful, or like a score, right? What is the probability that that shot was a free throw? So that's why we're finding the probability of a free throw given a successful shot, given a score, right? So probability of free throw given score, or success, in our table we wrote success here, so I'll just keep the similar wording. And that's going to be, well, out of our successful shots, right, which is 57.25 of them. So out of our successful shots, out of the 57.25 shots that were successful, the number that were free throws is basically 17.5. So given the 57.25 successful shots, the numbers that were free throws is 17.5. So our total probability is just going to be the 17.5 divided by 57.25. So 17.5 divided by 57.25. And that's correct. So now, all of these questions are very similar, right? You just have to look, because these are conditional probabilities, you don't want to look at this overall total here, right? You want to look at the total of the condition that you are given. Since we are given successes, or whatever we are given, right, we want to look at that marginal total, which is going to be in these margins here, right? We don't want to look at the grand total because we're dealing with a condition. So look at the total for that specific condition and then find out, whatever probability that we want to find, right? So here it's probably that a successful shot was a layup. So probably given our shot was a success, given that we got a score, what is the probability that was a layup? So probability of layup given success. So out of our 57.25 successful shots, the number that were layups is 33.75. So that's going to be our probability. So 33.75 divided by 57.25. All right, so finally, what is the probability that a successful shot? So given the shot was successful, given we got a score, what is the probability that was a three-pointer? So probability of three-pointer given a success. Well, the total number of successful shots is 57.25, right? Again, we're still looking at this column here. So out of my 57.25 successful shots, the number of three-pointers were only 6. So our final probability is just going to be 6 divided by 57.25. 0.25. And now you can kind of guess the next 3 questions. Before we were dealing with successes, so now we're going to be dealing more with failures, right? So what is the probability that an unsuccessful shot was a free throw? So given that we had an unsuccessful shot, right, given the shot was a miss or a failure, what's the probability that that shot was a free throw, right? So that's why it's probability of free throw given a failure. So probability a free throw given a fail is going to be, so out of 100 total shots, 42.75 were failures, right? So again, I'm basically only looking at this column here because that's the subset of the entire basically sample space that I want to look at, right? I only want to look at my failures, right? Because we are given that the shot is a failure, so I'm only looking at my failures. So I had 42.75 failures. And out of those 42.75 failures, how many were free throws? And remember, we're still following the number of successes divided by number of total because that's the definition of probability, right? So out of my 42.75 failures, I had basically 7.5 free throws. So that is going to be 7.5 divided by 42.75 is my answer. And then what is the probability that an unsuccessful shot was a layup? So given the shot was a miss or a failure, what is the probability that it was a layup? Well, it's kind of similar. Layup given a fail. Well, I still have out of my 42.75 failures, the number of shots that were layups is 11.25. So my final probability is just going to be 11.25 divided by 42.75. And then finally, what is the probability that an unsuccessful shot was a three-pointer? Right, so given that my shot was unsuccessful, right, given that my shot was a miss, what is the probability that it was a three-pointer? So this is the last conditional probability question, and we, solve it just like we did for the other ones. So probability of a three-pointer given a fail. So out of my 42.75 failures, right, basically 24 of those shots were 3-pointers. So 24 divided by 42.75 is my answer. And if you kind of view this probability with context, right, the 3-pointers are usually more challenging to get. So you know that the probability of a 3-pointer, given that it was a failure, is going to be higher than the probability of a 3-pointer, given that it was a success, right? So once you really start to understand the conditional probabilities, it's a good idea to check your final probability to make sure that it makes sense in the context of the question. If my probability of a 3-pointer given success was, an arbitrarily high value, well, you know that either the table's messed up or your math is messed up, because that doesn't really make sense in the context here, right? Especially if this number is greater than the 3-pointer given a failure, because we know that failures for 3-pointers happen much more. So our final probability is 24 divided by 42.75. And that is correct. So you know that this is how to kind of solve these conditional probability questions. For this one, there were basically 3 types of events, specific events that were happening. And though it might be confusing, it's a good idea to organize your probabilities so that you can really clearly see, which event occurs with what type of success or failure, right? So I hope this video was helpful. If you have any questions, let me know, and I'll see you next time. Bye.